What gives Velcro its stick? Why does pollen make some people sneeze? And how pure is the salt that you put on your food? The answer to each of these questions has one thing in common. It is too small to see with your naked eyes. But if you have a tool to make small things look bigger, you can answer these and many other questions. The subject of this episode of STEMflix is microscopy. No job is too small. Let's take a closer look.
Today's toughest challenges require teams of creative problem solvers who use science, technology, engineering, and mathematics to find solutions.
The world is made of very, very small things. Minerals give rocks and mountains their strength. Cells support life in us and all creatures. Then there are atoms, the building blocks of the world around us, without which there would be nothing. These things are so small that we can't see them with our naked eyes. So, to understand the world around us, we need microscopes. Here are some examples. A Swiss engineer who took frequent nature walks with his dog wondered why burrs stuck to his trousers and his fuzzy companion. A look under the microscope revealed that tiny hooks on the seeds cling to cloth and fur. That observation inspired him to invent Velcro. And, well, the idea stuck. Plants use pollen to reproduce. But why does it make some of us sneeze? Sixth grade students in Pasco, Washington took these images of pollen with a desktop scanning electron microscope. See the shapes and patterns? They help the pollen travel to their destination. But when that pollen winds up in our noses, our bodies treat it like dangerous foreign invaders. We fight back with snot and sneezes. Gross! Salt looks like a pretty pure substance, but is that all that's in your shaker? To find out, sprinkle a few grains on a glass slide under a microscope, then add water. Salt crystals dissolve, so what's left behind isn't salt. But what is it? Maybe it's another mineral, an impurity, or an ingredient added to prevent grains of salt from sticking together. Oh, and if you see little bubbles, your salt has gas. I mean, air trapped in its structure. So you see, microscopes help us observe the really, really small. And when you make an observation, that's when science and engineering begins. Speaking of which, I wonder what scientists and engineers are looking at with microscopes today. To find out, let's go to Pacific Northwest National Laboratory, a Department of Energy national lab in Richland, Washington. There, researchers tackle the world's greatest challenges. And I bet you they have a microscope or two.
My name is Megan Nims, and I'm a fisheries biologist at Pacific Northwest National Lab. Fish have these ear bones, and these ear bones grow with the fish every single day of their life. So the fish lay down a small ring, and these rings grow into annual rings, so it looks very much like rings on a tree. So these elements from every stream, river, tributary, ocean that they've been in throughout their entire life make it into this ear bone. So we can tell by looking at the elements that are in this ear bone, matching them to different bodies of water, where a fish was and when. And understanding those types of things can help us improve the health and sustainability of these fisheries populations. We use the compound microscope to first look at the features, the distinct features that we can see on these fish ear bones. The second type of microscope that we use is attached to a laser ablation unit. And so what we do is we use a laser to hit the surface of the ear bone, and that makes a small cloud of particles that is taken away to an instrument called a mass spectrometer, which can look at all the different elements and isotopes that were in that particular ear bone at that moment in time. I didn't go to school specifically to become a microscopist. I went to school with the goal of becoming a fisheries ecologist and fisheries biologist. But in doing that, I've become very familiar with microscopy because it's a very important tool in the work that I do.
I'm Shelley Conroy. I'm a postdoctoral researcher at PNNL, and specifically I'm working on electron microscopes. I do lots of different materials, from looking at samples in liquids to solids to even nuclear fuels. So my job is actually really quite fun. I think our research really matters because using the electron microscope we can actually make nuclear energy much safer, because now we can understand why certain faults and cracks happen in nuclear fuel. So we can use the microscope to go all the way down to the atomic resolution that we were never able to do before, because before we could only just visually see it with our eyes. We didn't really understand what was going on. But now we can just see slight changes in atoms, and even those slight changes can cause cracks and corrosion. So on a typical week, I could spend about half my time on a microscope, purely just because I also like working on the microscope. But actually there's a lot of work after taking those images, so the data analysis and then reconstruction, and with the advancements of microscopy, you actually, as a scientist, have to be getting better at all of those modeling tools and software. So usually I might be the only person that's a microscopist. Sometimes some other groups are actually all theory, so all physicists that use lots of different maths and modeling. And then in some other projects, we get to work with lots of different microscopists. I guess if I had to describe my job in one word, it would be evolving, because every single day I always get new samples and the science changes all the time. It's just fun, really.
So my name is Stephen Spurgeon. I'm a materials scientist and electron microscopist here at the lab. My research matters because we're trying to solve huge problems in understanding how to solve pollution, how to improve battery life, how to make hard drives bigger, how to make our computers faster. And so the way we can do that is by understanding the way materials are structured, how to control their chemistry, and then basically achieve the properties that we want. Transmission electron microscopy allows us to look at basically near single atoms in a material. When you look at a material at that level, you see all the beauty in everything. You see the symmetry, you see the order that's present in all types of materials. And it just really gives you a new perspective on everything that you see around you. Sometimes we intentionally introduce defects into those materials, and by controlling the distribution and type of those defects, we can get different properties. We can change the material's color, change the way it conducts electricity, heat, we can make it magnetic or non-magnetic. So we can change all these properties by engineering the material structure. Honestly, you're solving problems that have never been solved before. So really the first question is defining that problem. What do I want to answer? And is there a good reason to answer it? That's the first step. And then you might do things day in and day out without getting any positive results or something that looks like a positive result. And so it's really staying motivated through that work. And really what motivated me wasn't the idea of becoming a scientist so much as it was solving problems, answering questions. So our team here at the lab consists of a lot of different chemists, materials scientists, physicists that are involved at all different stages of fabricating materials, all the way up to imaging them and then developing a theoretical understanding of their properties.
It definitely takes a team to solve today's toughest challenges, and oftentimes that team includes a microscopist. Good thing that there are many different kinds of microscopes and microscopists to choose from at PNNL. And even though the things that they investigate are really small, they are not insignificant. Microscopes help us explore the world around us to make it safer, cleaner, and more understandable. You can expand your knowledge of the world too. Remember the salt experiment from earlier? That was recorded using an inexpensive 3D printed microscope that attaches to smartphones and tablets. Rebecca was one of the individuals who developed that microscope, which you can make for yourself. Check the description below for links to microscope printing instructions and for information on how to do the salt experiment. Remember, science and engineering start when you look. What will you discover?